So just before this, if you remember, we talk about test statistic based on t-test. Okay, if we don't know, if our samples are small, then we can use t-statistic. But at that point, we have to use degree. We had to find what is the degree of freedom. Okay, so that degree of freedom you cannot simply find using sample sizes. Sorry. To find that, you need this equation right here. Let me this equation right here. Okay, so try to use this equation and familiar with these values. All values are given. From the question you can find all these s1, s2, m, n, all values. Okay, always round this down. Okay, round down, always round down. For an example, if it is 8.5, this is going to be 8. Degree of freedom is 8. Always round down. Okay, if you have like 8.8, it's again 8. Always round down. Okay, okay. So same three methods we have to use, whether it is left tail, right tail, or two tail test. Critical value approach, same case. Okay, once you come to find the confidence interval for mu1 and mu2, we replace mu1 and mu2 from x bar and y bar to find the confidence intervals for mu1 and mu2. uh, Same here, it doesn't matter whether we are using t or c. We have to use alpha over 2. Okay, and degree of freedom, you have to find the degree of freedom, you have to use the previous equation. Okay, using that formula, plug the values, find v, then you can find the confidence intervals. I did this example right here using this dynamic group and static group. Okay, at the end of the class I think I finished this. To find the, okay, just check these. You have been given all the values. Okay, s1, x bar, s2, n2. So you have to simply plug the values to this equation, test statistic equation, and get the test statistic value. Okay, but at the same time you have to find v, degree of freedom. So they have found it here. Plug in the values. See, it is 17.82. They have rounded down. They have rounded down the value, which is 17. Okay, so based on this value, t alpha over 2, sorry, here it is t alpha, t alpha comma degree of freedom, it is, once you go to the t table, you can find value based on this is negative 1.74. Okay, negative because of the left tail test. Okay, this is a left tail test. See, okay. Based on that, you can find whether it is reject or not. In this case, it is reject. Okay, critical value approach. So part 2 of this question, to find a 90% confidence interval for mean difference mu1 minus mu2. Okay, so your alpha is 0.1. You have to find alpha over 2. Okay, you need since your degree of freedom you found in the last part, it is 17. So you can find test statistic value based on this. T alpha over 2, this is T alpha over 2 comma V. Okay. So that value 1.740. As I mentioned last time, you don't have to worry about negative or positive, because that negative or positive will cover from here. From the equation it will cover. So no problem with negative or positive. Then plug the values to your confidence interval formula and simplify it a little bit. You can get this answer at the end. Okay. Okay. Next part, pooled T procedure. We call this pooled T procedure. It is very similar to last case. I mean, the case we discussed just a minute ago. Uh, it's very similar, but here standard deviations are unknown. Still, we don't know about the standard deviation. Sample size is small, so we have to use t-test. That's why T procedure. But only difference is in this case, pool T procedure, sigma or standard deviations are equal. Okay, for an example, x bar, it has a standard deviation. Let's say STD, standard deviation is sigma 1. For second sample y bar, its standard deviation, it is sigma 2. So we, in this case, we assume that sigma 1 equals sigma 2. But again, we don't know these values. Okay, we don't know. Although we don't know this, we assume they are equal. Okay, so they have mentioned in this section, we are going to compare two population means. Yes, same as what we have done before. Samples are independent. The same situation. Okay, but there are two assumptions: standard deviation of population 1 and population 2. They are equal. This is the important point here. We use pool test, pool t-test, always if we have these standard deviations are equal. Okay, but standard deviation, they are, we don't know them, unknown. Okay, populations are normal distributed. It's just a general assumption what we mention if we need to use the T table. Okay, or T procedure. Okay. Okay, null and alternative hypothesis. Always null hypothesis is your mu1 equals to mu2. Alternative hypothesis, two tail test, right tail test, and left tail test. Okay, clear? This is the test statistic based on pooled t-test. Okay, it is this is what we used last time. This one. In this case also we use this, but in pool t-test, these two values, this one right here and this one right here, standard deviations, they are equal. See, two population standard deviations are equal. This one and this one equals to some value. Okay, which means they are equal. In general, we consider it as a sigma square, a common value. Okay, then you can replace these two values right here using this. Okay, so once you replace sigma 1 and sigma 2 using sigma, you will get your equation like this, right? So x1 bar minus x2 bar bracket mu1 minus mu2 divide by square root of sigma 1 squared mean sigma squared. Okay, divide by n1 plus sigma 2 squared mean just sigma squared from here, from this equation. It is n2. Okay, you can see, you can this value sigma squared is common, so you can take it out from this square root, so that you will get this equation right here. Okay, but the thing is, this guy sigma, you don't know, still you don't know about this sigma, because this case sigma unknown. Okay, so still we have a problem. Although we simplify it like this, we have a problem because we don't know this sigma yet. Okay, Since this is t statistic or t test, you know what to do. We have to what? We have to use sample standard deviation instead of sigma. Okay. Yes, we have to do it, but the problem is we have two samples. Okay. Those two samples, the standard deviations of those two samples are S1 and S2. So yes, we have to think about this. We cannot simply replace the sigma using S1 and S2. To do that, we have a special formula. Since population of standard deviation sigma is unknown, okay, where did this sigma come from? Sigma 1 equals sigma 2, right? It equals to sigma. That's the place where this sigma come from, okay? Is unknown. Yes, still we don't know this guy. Standard deviation, the simple estimate is called pooled sample standard deviation. To find this sigma, we use a procedure, we call it pooled sample standard deviation. So that pooled sample standard deviation denoted by SP, standard deviation P. This is standard deviation based on sample, that's why it is S, we denote by S. Sub P mean pooled. So again, you have a giant equation, giant formula to find that pooled sample standard deviation. Okay, see, you have to plug your S1, your S2, which means the sample standard deviations, that divide by N1 plus N2 minus 2. Okay. I think you don't have to, yes, you don't need to know how we get this formula right here. You can use the results, so no problem with that. Okay. So once you need to use the pool t test, you have to assume that okay, sample standard deviations are equal, but you don't know what is the sample standard deviation. You have to figure it out using this equation right here, SP. You have to find the SP. I think yes, they have mentioned it here. Once you figure it out SP, you can perform your pool t test. Same formula, numerator is same, but if you remember last slide we had sigma here instead SP. Okay, you have to replace sigma using SP. Okay, this has a t distribution. In this case, it is easy. You can find the degree of freedom simply adding those sample sizes and minus 2. Okay, degree of freedom you can find N1 plus N2 minus 2. Okay, do you remember how we find the degree of freedom for one sample case? So just for a moment, consider one sample t test. Okay, for that case, let's say n is the number of, I mean, a sample size. Okay, n is a sample size. So that case, degree of freedom we found using n minus 1. Okay, for one sample t test, degree of freedom n minus 1. Same here, this is like summation of those two degree of freedoms. Okay, here you have two samples like this. So here this for this one degree of freedom, let's say this is n1, this one n2 sample size. So here degree of freedom, if you consider they are like individual, I mean one sample t test, degree of freedom is here n1 minus 1, here n2 minus 1. Okay, so degree of freedom for both of them you can simplify using what, summation of these two, n1 minus 1 plus n2 minus 1. it equals to n1 plus n2 minus 2. It is what we have mentioned here. Okay. So for this degree of freedom, you don't have to use a giant equation like you had in the last case. But instead of that, you have to find SP using this. Okay. Any questions? Okay. I think let me no questions in the chat. Okay. I think you don't have questions. Okay. Okay. This is the summarize of what we have discussed so far. Pooled t-test. Okay. For the pooled t-test. Test statistic is what happened here. Where is this? Mu1, mu2. Okay, here they have assumed mu1, mu2, but you can simply assume that uh, mu1 and mu2 mu1 oh this goes mu1 and I cannot write it here. Okay, mu1 minus mu2. Okay, here they have considered this guy equals to 0. You will see why, because in pool t-test, normally we consider that I think we consider these scenarios. Okay, so in this case, whether mu1 greater than mu2, mu1 less than mu2, or not equal, something like that. Okay, for the null hypothesis, we use this mu1 equals mu2, so that you know mu1 minus mu2, it becomes 0. Okay, that's why we don't have this piece right here. See this piece here, it is equals to 0. Okay, so SP you can find using this equation right here. We call it pooled sample standard deviation. Since it is based on samples, we denote it by S. P mean pooled. Okay, so you have to use T table with degree of freedom using critical value approach or P value approach. Degree of freedom n1 minus n1 plus n2 minus 2. Okay, let's check this example. I think this is the only example that I have. This study based on gender about their sense of direction to spatial orientation in unfamiliar environments. There are 11 male and 11 female students. So this right here, let's say N1. Okay, female count I'll consider N2. Were selected and taken to unfamiliar park, gives some special orientation test point. Okay, at 10% significant level. So now you know your alpha. Alpha is 0.1. Okay. Data provides sufficient evidence to control that on average. Okay, this is what you need to figure it out. This is the researcher's claim. On average, male have low error on direction than female. Low error. So assume that the populations are normally okay. Populations are, which mean male population and female population, they are normal distributed, and population variances are equal, which mean sigma 1 or sigma is 1 is squared, sigma 2 is squared, they are equal, let's say sigma squared. Okay, so once you can see something like this, okay, variances are equal, and at the same time you will see that sample size are small. At that point you have to decide this is a pool t-test problem. Okay, so sorry, this is a pool t-test problem. They have given uh, x1 bar, which mean first sample mean, second sample mean, uh, first sample's standard deviation, second sample's standard deviation. Okay, now you have to figure it out whether this is a, I mean, this is a which kind of test. Your S note definitely. Uh, okay, first of all, you have to think about what is M1, mu1 and mu2. So I'll consider mu1 based on male population. Okay, mu1 is the male population's mean. Mu2 is the female uh, female population's mean of the female population. Okay, so I can write h naught mu1 equals mu2. Alternative hypothesis I can write, okay, alternative based on researchers claim, on average male have low error direction than female. Okay, mu1 based on, okay, mu1 and mu2 based on this average, which mean uh, average of error. Okay, mu1 and mu2. So okay, mu1 here, mu2 here. So average male have low error. They have low error. So which kind of test is this? It's gonna be right this. It's gonna be less than. I mean left tail test. Okay, it is less than, because see what they need to show, lower error. I mean on average male have low error on direction than females, so it is a left tail test. Okay, population mean error of male, population mean error of female. See mean error, so we are talking about mean error, not just the mean error. Okay, male it is mu1, female error it is mu2. So h naught doesn't matter, mu1 equals mu2, but alternative hypothesis mu1 less than mu2. Why less than? Because low error. Here they have mentioned, we need to check. On average male have low error on direction than female. Okay, so it is left tail test, alpha is given. In this case, since it is a pool t test, okay, you have to find the corresponding standard deviation. To find that, use this formula which I showed you last time. Plug the values to this formula and find SP. This is your pooled standard deviation, SP. So plug this SP into your test statistic. Here you can see mu1 equals mu2. So difference is 0. So there is no mu1 minus mu2 term. Plug all the values to this test statistic equation. Then you can find the TCAL or test statistic value. Okay. Now, what is the degree of freedom? You need to find the degree of freedom as well. Otherwise, you cannot find the T statistic value. Okay. Degree of freedom is N1 plus n2 minus 2. Oh, let me write it again. N1 plus n2 minus 2. Okay, so degree of freedom is 20 because n1 and n2 equals, I mean n1 equals 11, n2 equals 11. So they are 22 minus 2, 20. So now you can find t, now you have to find t alpha comma degree of freedom. It is this one. Alpha is 0.1, degree of freedom is 20. Go to the t table and find where what is the value belongs to t 0.1 comma 20. Okay, so that value is 1.325. 1.325. This side negative value because it is a left tail test. Because it is a left tail test. Okay, this is the critical value approach. Okay. So this is negative. Since it is left tail test, you have to get the negative sign here. So your value is here, somewhere here. What is the tcal? Tcal negative 97, negative 0.977. So where is the negative 0.977? It is somewhere here, right? Tcal is somewhere here. Now you can see that tcal value is not in the rejection region, which means we do not reject H0. Okay, we do not reject H0. So rest of the story you can write it's exactly same what we have done so far. Since it is not do not reject, you have to write this. Okay. Okay, let's check this one based on p value. Okay, using what is this page? Okay, sorry. Using p-value, same method, I mean, same problem using p-value approach. Step one, everything is very similar up to calculating the t-statistic. Yes, so step three, you have to figure it out the p-value. Yes, then plug this p-value into the t-statistic and find the t-cal. This is your t calculated value. Okay, since we are using p-value approach, you have to figure it out probability based on this tcal value. Okay, you can find the degree of freedom, and now you have to find alpha or probability value based on this I mean, let's say t theta comma degree of freedom. That value should be negative 0.977, 0.99772. Okay, go to the t table, find the corresponding theta value. Okay, based on this same thing we have done with the p values. Okay, since it is left tail test, okay, value is greater than 0.1. Okay, your alpha value is 0.1, right? Find that value. That value is what, 0.1. What's that p value? Where does that come from? So once you figure it out, this p value, you will see that p value greater than your what? That p value greater than p value greater than your alpha. Okay, so somewhere here. See, p value is greater than your alpha, mean it is 0.1 greater than this one. So we do not reject because it is your p value is not in the rejection region. So simply we do not reject. Clear? Okay, any questions based on this? We have to talk about confidence interval as well. I think this is the last part of this section. Let's talk about confidence interval. Okay, sorry, confidence intervals. So to find the confidence interval, uh, in this case, pooled t-test case, population with equal standard deviation, okay, pooled t-test. We made assumptions. These are the same, these are the similar assumptions what we have done last time as well. SRS, simple random sample. Our samples came from simple random samples. Samples are independent. Okay, samples are independent. They are independent. Uh, Populations are normal distributed. We assume that population are normal distributed, although our sample is small. Equal population standard deviation, which means sigma 1 equals sigma 2. We denote it sigma. Okay. So confidence interval we can find using the same procedure here. The only difference is T alpha over 2 comma V. This V is what? N1. This V you can find N1 plus N2 minus 2. Okay. This SP you have to find using the using that equation. Okay. This is the pooled standard deviation. Pooled standard deviation. Okay. So you can find the confidence interval for mu1 minus mu2 using this formula. Okay. Yeah, we have another part for this one. Okay, let's find the confidence interval. Alpha, this based on the previous question. So alpha 0.1, you had find alpha over 2, which is 0.05. So go to the t table and find t 0.05 comma 20. 20 is the degree of freedom. Okay, 20 is the degree of freedom. This is your alpha over 2. So this value right here, alpha 0.05 degree of freedom 20, t value is 1.725. Plug that 1.725 to this equation and you will see once you simplify this, so this is x bar or x1 bar. This is x1 bar. This is x2 bar. This is your this value. And this one right here is your pooled standard deviation. Again, this 11 is N1, this 11 is N2. Okay, once you plug those values, you will get the corresponding interval. Okay, 90% confidence interval for mean difference. Okay,